Hi YouTube, this is Joe Calton with Calton Cutlery. You can find us on the web, caltoncutlery.com. I just finished building a new grinder. Thought I'd show it off a little bit, explain how it works. Well, yeah, just show off a new grinder. What else do you do when you got a new grinder except for show the whole world about it, right? Um, normally I run the upright style of grinders, the upright two-wheel style. I'm a flat grind and convex grind kind of guy, so I don't normally do hollow grinds. But the only time that I need to hollow grind something uh, is, let's say that I need to hollow out the tang for something, uh, either to decrease the weight or to um, provide a space for more epoxy for the handle attachment. Um, I had a customer ask me for a big chopper with some fullers a while back, and so I did come up with an attachment that would go onto the platen. It would clamp onto the platen uh, and come out so that I could do that job on one of my two-wheel grinders. It did work pretty good. I was able to make the fullers. They didn't look too bad, I thought, especially being the first time and not really being a hollow grind kind of guy. But I also needed to do a small wheel attachment. And I made several small wheel attachments. In fact, I converted the last one to work on this machine. I've got some more bearings on order. As soon as they come in, I'm going to go ahead and make a really nice small wheel attachment, just because I haven't been happy with anything that I've made yet. I mean, it worked, but not really as well as what I would like to. So I had to do some rearranging in the shop and cleaning up and getting ready for winter. Here pretty soon things are going to start getting really cold, and I won't want to do outside projects. So I went ahead and decided to take some time, rearrange the shop, make some additions, and then build this new grinder. I did have a motor picked out. This was supposed to be mostly a detail and a light use type of grinder because I don't use a wheel very much when I'm grinding. So that motor up there, I think it's just a half horse, and I kind of figured that would be plenty. But then I was surfing YouTube and I found where a guy built a really nice grinder out of a treadmill motor. And I'd heard everybody saying that treadmill motor-based grinders, they're kind of okay. Well, I didn't have any first-hand experience, and I just happened to pick up a used treadmill for fairly cheap. I think I spent 50 bucks on the treadmill at the local thrift store, and thought, well, heck, why not? Build the thing and let's see what happens. I want to say, of course, the motor is inside that box that's behind the 4x36. It's just made out of 1/4-inch plywood. So the details on the motor are kind of hidden right now, but it is a 2-horse DC, variable speed, of course, and I want to say it pulls like 10 amps, if I remember right. So, it's a fairly decent sized motor. The thing is really tiny though. I mean, it's about that big around, maybe 3 or 4 inches in diameter, whereas a 2-horse AC motor is that big old beast. Anyway, so went down to the steel yard, picked up about 50 bucks worth of steel for the base plate. Just a 1/4-inch thick base plate. It's I don't know, 1.5 feet wide and 2 foot long. It was something that they already had cut, because I don't really have a whole lot to cut the bigger pieces out. I mean, I can cut it with an acetylene torch, but then you're spending half the day grinding and cleaning it up. Have another piece of 1/4-inch plate that I welded to the bottom of this upright, which is 2 inches by 3.5 or 4 inches or so. And usually at least when I weld anything, there's quite a bit of distortion. Sometimes I get lucky and there's not a whole lot. Other times, man, things warp all over the place. So I welded the upright to the upright base plate, and then drilled holes through both of them, the upright base plate and the machine base plate, and then bolted it together. Just drilled those holes oversized for the bolt size that I was using, so you can loosen these bolts up and kind of twist it, tweak it, you know, position it where you need it, and then tighten everything down and it stays put. The tracking assembly is just like the tracking assembly on my upright grinders. This is 1-inch, probably 16th inch tubing or walled tubing. I can't see the screen, so I'm hoping you're getting a good shot of everything up there. You got these pieces welded in place. There's not a whole lot of slop, you know, side to side around the upright. Another cross piece, and then this piece of 1/4 inch angle iron is welded to the tubing. Then you have got a bolt that runs through a hole in this piece of angle iron, and that's where it attaches onto this piece of angle iron. So you have a pivot, and then just a bolt with a T-handle welded onto it and a tapped hole to push this down or to let it come back up under spring tension from the back. This tracking wheel, I casted it out of scrap aluminum and some pop cans. And then I just took the bearings out of this I took them out of the rollers from the treadmill. What I did was I cast a soup can full of aluminum, then chucked it. Once it cooled, then I chucked it up in the lathe, cleaned it up, got rid of the little ridges that'll show up in the sides of the soup can, cleaned all that up, faced off the ends, and then marked out how wide I wanted the tracking wheel to be. It's a little bit wider than what I was after, but not by much. And then bored a hole clean through it, and then bored out the holes on the sides for the bearings. Then I used the shaft that was on that was inside the treadmill roller, since it was sized to fit the inside dimension of the bearings, and it wasn't threaded on the end, so I ended up had to thread the end for a nut, and then I welded the other end of the shaft up to this piece of angle iron. So it's a pretty solid unit. If you have to replace the bearings, you just take this nut off, which it's a can't remember what they're called, the nut with the plastic sleeve inside of it so that it won't back out. Anyway, take that nut off, slide this wheel assembly off, replace your bearings, put it back on, tighten your nut back up, and adjust the tension on this nut for your bearings, and away you go. The drive wheel is also cast out of aluminum, and it was part of the same can that the tracking wheel came off of. And I turned it down to, you know, the size really doesn't matter so much since this is a variable speed machine, but turned it down, bored a hole in the side of it for the treadmill motor shaft, and then probably not going to be able to see that all that well, but then I drilled a hole from the end clear through to the center, and then I had to step it so that my tap would go all the way to the center, because this is about a 3.5 inch diameter wheel. Tapped a hole for 1/4 inch by 20, I believe, bolt. Ran the bolt in there until it just came through the other side, pulled it back out, cut it off with a bandsaw, cut a slot in it with the bandsaw for a flathead screwdriver, and bam, got a nice set screw to hold everything in place. This wheel right here is probably not going to be on there for very much longer. It was one of the wheels that I made for originally it was used in a 2-wheel grinder build, and it was a tracking wheel, but I ended up taking it off and squaring it up and using it as one of those ones that I had the attachment for to bolt up to the platen on this machine. And it does work, but as soon as I get the bearings in, I'll go ahead and cast up a whole bunch of different wheels of different sizes. Put real good bearings in them. This is just a water pump bearing, which they work pretty good, but they're not as nice as brand spanking new bearings. Let's see, it does have the arm style of removable tooling, you know, so I can pull this down, take the belt off, loosen up these two bolts, which I just drilled a hole through the side of this tubing, and then big enough for this bolt to pass through it without touching the sides, and then grabbed a nut of the right size and then welded the nut onto the tubing, and then welded a piece of cold roll onto the top of the bolt so it makes a nice T-handle. But you loosen those up, you can pull that arm out. This is a 5-inch wheel. You can go to the small wheel attachment, or go to the 2-inch attachment. So like I said, I'll go ahead and you know, when I have spare time, go ahead and cast up more aluminum to make different size contact wheels, and then probably find some sort of a sheet rubber or neoprene, like this wheel is here. It's a production made wheel, and it wasn't really all that bad in price. I just want to see if I can make the other ones also. You still have the control for the treadmill. I have not found I'm pretty light on electronics, so I haven't found the right switch, you know, that'll vary this yet, so that I can get rid of this and put the on-off switch in a regular box, mount it to the side of the frame, and then, you know, put that other switch and mount it real good. So right now it's just held in place with a screw. This arm right here that accepts your tooling arms is bolted up to the upright. So if I find out later I need to shim it one way or another, or add spacers or remove them, you know, that's all good too. And then the box. Okay, so this treadmill motor is a 2-horse DC motor, but it is an open frame. Plus it has all the controls that control, you know, the speed of the treadmill, and the transformer that turns the 120 volt electricity into, I can't remember what voltage the motor is, but all that needs to be protected, especially the motor, because it is an open frame. So, you know, when you're grinding, you're producing an awful lot of dust. I mean, you can see all this dust right here. That's bone dust. My brother-in-law brought over a deer that he was doing a European mount on, and needed to square up the base of the skull, so he ground that on this 4x36. So anyway, all that dust can't get into the inside of that motor. So what I did was I just built a simple box out of 1/4-inch plywood, and it's all screwed together. And then these blower motors right here, I get them out of old dishwashers from my appliance repairman. So I chopped a hole in the top board of this, and then that is just some filter material. I went down and grabbed a cheap 20 by 20 by 1 inch furnace filter, cut a chunk of it out, and just to get me going, I slipped that in between the blower and the box. There is no outlet dedicated hole in this box. I'm relying on my not so good carpentry skills, and you know, the little gaps that are here and there, especially around the front where the drive shaft has got to come through. So pretty much this just pressurizes the inside of this box with clean filtered air. When that fan is running, you can hold your hand up to the cracks and there's airflow coming out of it. So as long as this is pressurized and there's airflow coming out of it, that means dust isn't going to go back in there, because it's not pressurized dust going inside of it. Then I wired up the blower onto the main on-off switch for the treadmill control. So the second you go to turn that on, that fan kicks on. So anytime the grinder's running, that fan is blowing automatically. And then of course you guys will want to see it run. And of course I changed out the tracking arms, so we'll have to adjust the tracking a little bit. There we go. This build has been a little bit tougher than a normal two-wheel style grinder build, just because of the added wheel. You know, in a two-wheel style grinder, you have two wheels to line up between each other, and that's it. This style of grinder, not only do you have three wheels to line up on the initial build, but anytime you build another arm that's got another wheel, then that arm has got to be built in such a fashion that it's also keeping that wheel in line with the other two, or in line enough, you know, to be able to get whatever type of grind that you're after done. So it was a little bit more challenging, and there still are a few more tweaks to make and everything, but you know, the really nice thing is so far, and I haven't ground a knife with it yet, I've ground some on strap, I haven't been able to bog down that DC motor. Hang on, we'll turn it up a little bit so you can see the variable speed. And it seems to run fairly smooth. You know, I'm sure it'll get better the more I work with it and the more I decide to, you know, to tweak everything up a little bit. But you know, it sure seems to be a nice grinder, and you know, I don't hollow grind a whole lot. Like I said, mostly it's for hollow grinding tangs. And then I've got one customer that likes fullers. I'll probably get a couple more customers that like fullers, so I'll play with that some more. The small wheel attachment for the inside of finger choils and such, like on this Carter pattern necker, that's really really nice to do on a small wheel grinder instead of, you know, handheld with a Dremel tool, or, you know, chucked up you know, an old dowel with paper wrapped around it in a drill press. You know, this works just so much slicker than that, especially when you're doing, say, 10 or 20 of them at a time. But it seems to be a good grind. Oh, I was talking about bogging it down. You know, everybody talks about needing lots and lots of power for your grinder so that you can't bog it down. You know, the first grinder that I built is this one, and it runs on a 1-horse 3600 RPM motor with a 5-inch drive wheel. And yes, you can bog that motor down, but while you're bogging that motor down, generally speaking, you're putting entirely too much heat into whatever it is you're working on. Even with a very fresh belt, you know, and I guess it doesn't really matter so much if you're working annealed steel or if you're just rough grinding, but really, if you've got to put that much pressure into something that you're worried about bogging down a 1-horse motor, then you ought to change belts, or, you know, do something else a little bit different. The more and more pressure you put into that blade while you're grinding it, not only are you producing more and more heat, which, you know, could be important to you, could not be important to you, either way, but you're producing more heat and you're also losing control. The second you start putting more and more pressure into that blade, you start losing control over your grinds, over your heat. Boy, let me tell you, if you've ever been really bearing into a belt that was running fast, like on this one runs at about 5,500 surface feet per minute. When you're really leaning into something like that and you have a heavy belt that breaks, oh boy, let me tell you, that's pretty exciting. In fact, as soon as a belt breaks like that, the second you know, realize what's happening, get the machine shut off, get the belt or the pieces of the belt that, you know, are tangled up and everything, get them all clear. Before you do anything else, you ought to get back on that grinder with another belt and, you know, grind another knife or two out. Otherwise, you start to get kind of timid, you know, stepping up to that grinder. Well, what happens if it breaks this time? And if you're concentrating on that, then you're not concentrating on nice, good grinds. So yeah, you know, I mean, I think, I mean, this one's got a 1 horse, this one's got a 2 horse, but it does have a run capacitor, which I don't think it does give a true 2 horse. And this is a 2 horse DC, and I haven't been able to bog it down. Of course, I do grind a little bit on the light side. If you're bearing down too hard on your grinding, you need a new belt. Anyway, it's been an enjoyable build. I think it's going to be a great addition to the shop. Even just as it is, and I'm sure it's only going to get better over the next couple of weeks or months or years worth of using it and refining everything, tweaking it. Heck, I might even paint it. Nah, I'm just kidding about that. I'll never paint it. Rust is a really nice color for a shop. Hope you guys enjoyed it, and we'll see you next time.